Well, hi everybody. We have navigation we're going to talk about, and we're going to talk about nautical navigation, which is in the common way that sailors will talk about the direction or which way they're headed, their bearings. Now, nautical, the acute angle that a path or line of sight makes with a fixed north-south line. So it'll look like this. You have your north or your south, and then how far off you are from that north or south line. So for example, 25 degrees or south, 25 degrees east. So if I'm right here, if I make that, and I just kind of draw a south line and then go east off of that 25 degrees, my line, the direction I'm going is right here, and that's 25 degrees that way. Now, north, 75 degrees west, so if I kind of draw that northern line there, and I go 75 degrees off of that, 75 degrees this way, this is the direction that I'm headed. North, 50 degrees east. So if I go this way, and then I go off of north, 50 degrees, maybe about like that, that's the direction I'm headed with that. So that's just kind of a general description of what these expressions give us for direction. I want to do one example here. A sailboat leaves a pier heading due west at 8 knots. I want to try to draw that. So here's the pier, and I'm going to go due west at 8 knots. Now a knot, that's another nautical term, is nautical miles per hour. Now, nautical miles are real close to the miles we know on land. So 1 nautical mile is approximately 1.15 miles. So they're very close to each other, but 8 knots is 8 nautical miles per hour. So after 15 minutes, all right, so I'm curious here, let me grab my handy dandy calculator. Now, in 15 minutes, you've gone a quarter of an hour. In 1 hour, you would go 8 miles, 8 nautical miles. Okay? In a quarter of that, you would go 2 nautical miles. Now, write 2 NMI. Now, the sailboat changes course to north. So I'll let this be so now the sailboat has gone to here, from the pier to here, and it changes course from north 16 degrees west. So I'm going to go 16 degrees off of this angle right here. So this is 16 degrees here at 10 knots. Find the sailboat's bearing and distance from the pier after 12 minutes on this new course. All right, so 12 minutes here. Now, 12 minutes is 1/5 of an hour. 12 minutes is 1/5 of an hour. So in an hour, they go 10 knots. 1/5 of that, so that's another 2 nautical miles. So, okay, find the sailboat's bearing and distance from the pier 12 minutes after on this course. So we want to find just from the pier how far has the boat traveled. I'll kind of make this my X. And we also want to find like the bearing. But to do that, I'm just going to find theta. That's not going to tell me the bearing. I'll interpret into the bearing after I find this theta, but I want to find that within this triangle. And one of the things we can do here, okay, so what I'm going to do here is I'm going to kind of complete this and make a right triangle going all the way west and then going all the way north here. Okay, now this triangle that I have here, these are complementary angles. This is off of 16 off of north, so the rest would be here to that due west, and that would be 74 degrees. That is 90 degrees. Remember, this is 2. I got a little bit, 2 is nautical miles, is that distance there. So this is 74 degrees. I'm going to call this side A and this side B. And then just kind of do some of this math. I want to work within this triangle. So I got a 74 degree angle. I got a hypotenuse of 2 nautical miles when I'm looking inside this triangle right here. So if I want to get B, that's opposite over hypotenuse. So the sine of 74 degrees is equal to B over 2. If I multiply both sides by 2, B is equal to 2 times the sine of 74 degrees. I'm going to round to the nearest hundredth on all this. I want to check my mode because we're working in degrees right now. So my mode's in radians. I'm changing that. And then 2 sine 74 is 1.92 miles. So B is approximately 1.92 nautical miles, I should say. This is 1.92 nautical miles. And then you can use Pythagorean theorem, or you can use another trig function to find A. I think A is important to have. So I'm going to, I'll just use another trig function. And we'll go cosine of 74 degrees is equal to adjacent A over hypotenuse 2. So A is equal to 2 times the cosine of 74 degrees. 2 cosine 74 is 0.55. A is approximately 0.55 nautical miles. So this is 0.55 nautical miles. Now, I think I'm good to find theta because now this whole side here is 2.55. The entire western parameter there is 2.55 miles. The northern parameter is 1.92 nautical miles. So, to find theta, I'm going to take the opposite over the adjacent, okay, and I'm going to take the inverse tangent of that. All right, and then second tan 1.92 divided by 2.55 is 36.98 degrees. Okay, so this in here is a 36.98 degree angle. Now, remember the acute angle, if I go off of south, that is that's an obtuse angle. So we're going to go off of north. So my bearing, I'm going to take, these are complementary angles, I'm going to take 90 degrees minus 36.98 degrees. My bearing is north, and we're going west off of north. This is to the west. But how many degrees is that? So 90 minus 36.90 minus 37 is 53. So I'm going to go 53.02 degrees. So the bearing is north, 53.02 degrees west. And the distance, the nautical miles there, I'm going to use Pythagorean theorem for that. I'm going to take 1.92 squared plus 2.55 squared to get x squared. And that's 10.1889 equals x squared. And I'm going to take the square root of that. And I get 3.19 nautical miles. So we are 3.19 nautical miles with this bearing. All right. Okay, well, we also have air navigation, and a lot of times air navigation is just measured degrees clockwise from the north. Okay, so if I am at this point right here, and I am going a direction of 37 degrees, here's north, just go 37 degrees off of this northern side. This is 37 degrees here. That's the direction you're headed. If it's 106 degrees, they say that the bearing is 106 degrees. Okay, well, you got this. You might want to think of an east-west here. If you're right here, all right, your angle is, there's 90, so your angle might be, this is 16 degrees this way, but the whole angle is 106 degrees off of north, so you'd be headed that direction. If you were going 305 degrees, if your bearing was 305 degrees, oh, okay, I don't know why I just drew that, but let's say you're right here, 305 degrees, 190, 270, and 35 more, so you are probably going that direction right there, if your bearing is 305 degrees. So, an airplane flies on a course of 200 degrees for 150 kilometers. How far south is the airplane from where it originates? All right, here's where it's originated. Here's kind of the north line that we're going to measure off of. And we're going to go 200 degrees. So we start up here and go like this. This is 180 and 20 more. So that's 200 degrees. And we have flown for 150 kilometers. Let's get some of these angles in here. This is a 20-degree angle right there. So we actually are asking for, I'll just use S here. S is not always the best choice for variables for me, but right there. This is our triangle then. I want 180 and 20 more because of the 200-degree bearing. And so I want to know what S is. I've got this right triangle. I got 20 degrees here. 150 is a hypotenuse. S is the adjacent side. So S is the adjacent hypotenuse inverse cosine of, okay, let me start again here. That's not quite the direction I wanted to go there. Okay, we got S. Let's just set it up. The cosine of 20 degrees is equal to S. I started going solving for angle, and that's not what I'm solving for on this. Cosine of 20 degrees is S over 150. If I multiply both sides by 150, okay, 150 times the cosine of 20 is 140.95. So S is 140.95 miles. So the plane has flown 140.95 miles south. The plane is right here, but its southerly direction is 140.95 miles from where it was. Now, it's also west of where it was too, but it just asked for the southern. All right, guys, take care.